So this is the new update for mySQM Plus version 134.04, and the purpose of the video is to introduce the changes that have taken place from the previous versions. Here, this is the controller config. First thing to note here is that we are now using Arduino Core 207. Alright, so let me just go back to controller config, and all this is okay. But in servers you now have a thing called a Debug Server, which can write to a TCP/IP port 9090, and it's not intended that you should disable this thing. You should run it all the time, and maybe in future releases you won't be able to define this. It'll just be part of the default package. Alright, so that's the debug server. Let's go and have a look at some stuff. The management server, I've now defined the management server print debugging, and what I'll do is I'll go and show you this thing in working. So what I want to do is I want to start up myQueryApp. So let's just go there and do this. There it is. Let me just sit back to that. So here it is, and I've got logging enabled. So if I go connect and I go to main, the reason why you have to use myQueryApp is because if you use a web browser, it doesn't keep the connection open and disconnects. So myQueryApp is designed to keep the connection. And I know that I've got the debug print enabled in the management server, so when I do this, I would expect that back inside, I've got some information now, which has been sent to the debug port. Nothing's in the serial port, notice that? So let's just go back and change this to serial, and we'll do the same thing again. So you can see here we've got this message coming from the serial port, and in the query app there's no additional information. See that? It's actually gone to the serial port instead. So let me just close this and open up the drive, and I've got myQueryApp here. So I can log, and you can see here that the information which was sent to the debug server on port 9090 has actually been written to a log file. So that's all working. Right, so next up is the rain tipping bucket and WindSpeed classes, and these things have undergone quite some change. All this information here is just to help make the debug server run properly, so don't change any of this code. I can just come down a wee bit, and we've got choices now between running old code and running new code, and it uses a check when an interrupt occurs. This new code here comes from the help with Graham, who started this process, and basically what it does is it checks to make sure that the interrupt of the pulse that's coming in is actually a genuine pulse and not some form of interrupt bounce, because the response times for interrupts on an ESP32 is very, very small. So the WindSpeed code and the rainBucket code are very, very similar. Where's rainBucket? It's very similar, except for the fact that the rainBucket code actually counts in milliseconds, whereas the WindSpeed code actually handles microseconds. So even though the values might look the same, they're not, because the unit of measurement's different. Alright, so this is now supported by a new admin page, and it's not from the menu here. You can't get it from the menu because it's not intended for you to actually use this all the time. Alright, so we've got options for it. So it's use old code. When it's disabled, it means it's running the new code, and I can just switch it like this, and completely everything's now been updated, and it will use the old code before that was in version 133 and below. Or if it's disabled, it will actually run the new code. And the same applies to the WindSpeed settings as well. The other thing you find here is called a minimum pulse width, and this is the check that the interrupt code uses to decide whether or not it's a pulse trigger or a genuine pulse. And so in this particular instance, it has a range of 10 to 200 milliseconds, and it's set to 60 milliseconds for the rainBucket, because the rainBucket is a tipping thing backwards and forwards, and the speed at which that happens is not very fast, so the pulses tend to be longer. In this particular case, for WindSpeed, the pulse width is from 100 to 800 microseconds, and I've currently got mine setting to 254. And the idea is that if you're going to use the new code, you need to set these things up to ensure that they will actually work properly. So the idea is put a fan in front of your WindSpeed sensor to run it around, and then decide whether or not that speed is being pulse triggered or whether in fact it was reading genuine. So you'd basically drop, say, maybe 10 or 20 steps at a time from the default, and you can set this. It takes 30 seconds for this to refresh, so don't expect the WindSpeed to have an immediate effect in WindSpeed values until a 30-second cycle's elapsed. All right. So that's both rainBucket and WindSpeed, and those are the major changes associated with this. Is that every file's been changed to now use these new debug macros to work with the Debug Server, so please don't change any of that. Some portions of MQTT publish code were changed because it was actually executing it twice. mySQM has been updated by Paul to version 11, and it uses Python 3. I've updated some of the client-side examples. So if you wanted to use the Debug Server, what you do is you make sure it's defined in controller config, and then, for example, if you're having problems with Weather Underground, you'd come into here, you'd enable this debugging code inside Weather Underground, and you would of course have Weather Underground enabled here. Where is it? There. Then you'd program the controller, and using myQueryApp you can log all of these Weather Underground messages to the Debug Server to a file, The one thing I should have mentioned about the debug server is that boot print here will always go to the serial port. It won't go to the debug server, because if you were trying to print out boot messages while it's booting up, the debug server hasn't even been loaded. So it doesn't make any sense to send boot print messages to the debug server at boot time. So those messages by default will always go to the serial port. Alright, so the other big change, of course, is the new ASCOM driver. So let me just find something here. So let me just run Nina. Right, and let me go down, of course, to weather, and let me, so it's called mySQM plus ASCOM OC, and you just go into settings. At the moment, this is it. I've set up the TCP/IP, I've got trace on, etc., and I can go connect, and then of course I can actually connect to the drive. You see that it's connected, and I've got values here of temperature, humidity, dew point, pressure, cloud cover, rain rate, etc. All these information is actually here inside Nina. So that's prior to this, prior to version 24 of the ASCOM driver. It didn't work very well, but the new release actually works fine.